Topics covered in quadratic equations. Welcome to our study of quadratic equations. This chapter serves as a fundamental pillar of algebra, acting as a vital bridge between the basic linear equations you are already familiar with and more complex polynomial functions. By definition, a quadratic equation is a second-degree polynomial in a single variable, which simply means that the highest exponent of the variable is 2. As we progress through this chapter, we will focus on 3 key learning objectives. First, we will establish a conceptual foundation by understanding the standard form of a quadratic equation, which is expressed as ax squared plus bx plus c equals 0. Second, we will master the methodology of solutions, specifically focusing on the technique of factorization, also known as splitting the middle term. Finally, we will learn how to analyze the nature of the roots, determining whether they are real, equal, or imaginary, by utilizing a mathematical tool called the discriminant. Once we have mastered these mathematical foundations, we will move on to explore how these equations are applied to solve practical, real-world problems in fields like physics, engineering, and economics. Real-world applications of quadratic equations. Now that we have established the mathematical definition and our learning objectives, you might be wondering, where do we actually see these equations in action? The application of quadratic equations extends far beyond the classroom, playing a critical role in various scientific and professional disciplines. In physics, for instance, quadratic equations are essential for modeling projectile motion. The path of any object thrown into the air, such as a ball or a rocket, follows a parabolic curve, which is mathematically described by a quadratic function. In engineering and architecture, the properties of parabolas are vital for designing suspension bridges, satellite dishes, and reflective telescopes to ensure both structural integrity and optimal signal reflection. Moving to economics and business, quadratic functions are used to model cost and revenue curves. This allows businesses to calculate the break-even point and determine the specific price point that maximizes total profit. Lastly, in geometry, these equations are frequently used to calculate the dimensions and areas of shapes where one dimension is defined in relation to another. Understanding these real-world connections will help you see the true power of the algebraic tools we are about to master.